So today we're going to talk about the testing the hypothesis about the population parameters. Okay. So previously, if I would like to calculate the average IQ score of all the students here, I took a sample, we calculate the average of the sample, and we constructed the confidence interval around the sample, right? For example, if the sample's average is 70, if our error margin is 10, I would say, hey, I would estimate the population, the average score of all the students in this, average IQ scores of all the students in this university between 60 and 80, okay? Now, let's assume we're given some hypothesis about the population parameter. For example, we're given that for example, the manufacturer of the rechargeable batteries, they say that their batteries are good in average for at least 1,000 charges. Okay, so they are telling us something. So they're telling their estimates about the population parameter, right? They say that the mu is more or equal to the 1,000, right? So now we would like to test this hypothesis. Okay, in order to test this hypothesis, so we are going to take the sample and we're going to calculate some measurements in order to say at the end whether this is true or this is not true. Okay, do you understand what does it mean, the hypothesis test, right? Previously, we constructed this parameter, we estimated this parameter. Now, someone has already estimated this. We're going to test this estimate, okay? So we are going to differentiate the two types of the hypothesis. Could you, the null hypothesis is the statistical hypothesis that contains the statement with the equality sign. And the alternative hypothesis, it's the complement of the null hypothesis, okay? So in every problem we're going to have the claim, and for every claim, we're going to define the null hypothesis and alternative hypothesis, and we're going to define what is our claim, so whether it is the null hypothesis or the alternative hypothesis. So as an example, let's consider this. So it is better for us to write down the claim, the verbal claim, as in a mathematical form. So let's say the manufacturer claims that their batteries are good for at least 1,000 charges. What does it mean in average? So it means that if you take the average lifetime of the batteries, the average lifetime is more or equal to the 1,000, right? So if the producer says that their batteries are good in average for more than at least 1,000 charges, it means that the mu, the average lifetime of all the batteries, is more or equal to the 1,000. Okay? This is going to be the claim. And for this claim, I'm going to calculate the null hypothesis and alternative hypothesis. So null hypothesis is a statistical statement which has the equality sign, okay? So in this case, it is going to be null hypothesis is going to be more or equal to the 1,000, and the alternative hypothesis, it's its complement. What is the complement of the null hypothesis? It's a mu is less than 1,000, okay? Complement. So our claim in this case is the null hypothesis, okay? So let's assume that after I calculated the average IQ of all the students, so I would like to estimate the average IQ of all the students. And I'm claiming, hey, the average of IQ of all the students in this university is more than 80. Okay? So for this claim, I'm going to construct the null hypothesis and alternative hypothesis. What is going to be the null hypothesis in our case and alternative hypothesis in our case? So mu is more than 80 is going to be the alternative hypothesis. And what is going to be the null hypothesis? It's its complement. It's going to be mu is less or equal to the 80. Okay? So it's complement of the alternative hypothesis. So this is our claim. complements, right? So you see, so we have three things here. We have got the claim, we've got the null hypothesis, and alternative hypothesis. For each given claim, we're going to construct the null hypothesis and alternative hypothesis always, okay? Depending on the psi of the hypothesis, we're going to define what is the null hypothesis and what is the alternative hypothesis. For example, in the first case, mu is more or equal to the 1,000. So alternative hypothesis would be the claim which contains the equality sign, right? More or equal has the equality sign, right? It's going to be the null hypothesis. And its complement is mu is less than 1,000. It's going to be the alternative hypothesis. So the next example, mu is more than 80. It doesn't have the equality sign, right? It is going to be the alternative hypothesis. And the null hypothesis is going to be its complement, okay? For example, if I say that, hey, the average score after the midterm for this group is less than 55, okay? So what is going to be the alternative hypothesis and what is going to be the null hypothesis? Alternative hypothesis is mu is less than 55 because it doesn't have the equality sign, right? And its opposite, its complement, mu is more or equal to the 55, it's going to be the null hypothesis. In this case, our claim again is the alternative hypothesis, okay? So let's calculate, I measure the average height of the students, and I'm saying the average height of the students for me, average height of the male students in this university is equal to the 1.75, for example. This is my claim. So what is going to be the null hypothesis and what is going to be the alternative hypothesis? So it has the equality sign, right? So the null hypothesis is going to be mu is equal to the 1.75, and alternative hypothesis should be its complement. It's going to be mu is not equal to the 1.75, okay? In this case, our claim is the null hypothesis, right? For each given claim, first of all, we are going to construct the null hypothesis and the alternative hypothesis, okay? So if your claim has equality sign, then it's going to be the null hypothesis, and you construct the complement of this alternative hypothesis by taking the complement of the statement. If your hypothesis does not have the equality sign, then this is going to be the alternative hypothesis, and you construct the null hypothesis by taking the complement of the statement, okay? So here are a couple of examples here. For example, the Stateswell College claims that 94% of their graduates find a job within 6 months after the graduation. So what is the statement, mathematical statement here? What is the mathematical statement here? Mu is equal to the 0.9, or P. It's telling us about the proportions, right? So after the students has graduated, 94% of them have found a job within 6 months, okay? This is what the administration of the college is telling us, right? P is equal to the 0.95. It's the statement, right? So what is going to be the null hypothesis in this case? P is equal to the 0.95 is the null hypothesis, right? Because it has the equality sign, right? And alternative hypothesis, it's going to be P is not equal to the 0.95, okay? So one of the hypotheses, the null hypothesis or alternative hypothesis, should be equal to your statement, okay? For example, if it would be given P is less or equal to the 94, then a null hypothesis would be less or equal to the 94, and the alternative would be more than 94, okay? No. This is the statement. We're talking about the numerical, like estimates of the population inside your statement, right? So no matter what is your claim, we are always going to test the null hypothesis, okay? We are going to construct the null hypothesis and the alternative hypothesis for the claim, and then we're going to test the null hypothesis, whether this is true or this is false, okay? And then at the end, we're going to tell like two conclusions about the null hypothesis. Either we're going to reject the null hypothesis, either we're going to fail to reject the null hypothesis, okay? It means that there is not enough evidence to fail the null hypothesis, okay? We don't know. Maybe this is true, maybe this is false. But if it tests, and if you're going to reject the null hypothesis, we say that, hey, null hypothesis for this claim is false. Okay? And we are going to differentiate two types of the error. Type 1 error is when we reject the null hypothesis, which is true. Okay? So we are going to test the claim by constructing the null hypothesis and alternative hypothesis, and then we're going to test the null hypothesis by taking the sample and calculating the measurements of the sample. Okay? Obviously, it depends on how you're choosing the sample, how big your sample is, right? And you might have some errors. Okay? So type 1 error is when you reject the null hypothesis, depending on your test, even though that the null hypothesis is true. You're making the error, and this is going to be the type 1 error. Type 2 error is you're going to test the null hypothesis, and you couldn't fail this. You couldn't reject this null hypothesis. You're saying, hey, null hypothesis is true, even though actually it is false. Okay? In this case, we're going to make the type 2 error. Okay, so let's talk about how we're going to make the conclusions about the claims. Okay, so let's assume, so if the null we are going to test the null hypothesis, right? And we say that the null hypothesis is true. Okay, we're not going to reject the null hypothesis. It means that we have to reject the alternative hypothesis, right? So if the null hypothesis is wrong, we reject the null hypothesis. It means that we are going to support the alternative hypothesis. So in the hypothesis test, we're going to define the level of significance. So this is going to be denoted as alpha and beta. It means that what is the allowable measurement. So what is the maximum allowable probability of making the error? Okay? It means that if the alpha is 0.1, it means that probability that we're going to make the type 1 error is 10%. If the alpha is equal to the 0.01, it means that the probability that we're going to make the type 1 error is 1%, and so on. So do you remember when we talk about the confidence intervals, we talk about the level of confidence, right? So depending on our level of confidence, we're going to define the size of the interval, right? So here's the same. So we're going to measure some probabilities. We're going to measure some numerical measurements of the sample. And we're going to compare this with this alpha, okay? Level of significance. So depending on which alpha you've chosen, so you might get like a different result. So basically, do you remember in the calculus 1 also, we wrote down the programs with epsilon, right? Especially for the iterational methods, when we wrote the program, we need to decide where to stop these iterations, right? So usually we used to compare the result from the previous iteration in order to stop this, right? So when you compare this, you need to subtract the 2 results from the 2 consecutive iterations, and you need to compare this with some small number epsilon. You remember this? Okay. So after we state the null hypothesis and alternative hypothesis, we are going to compute the test statistic. So depending on what is the statement is about, we're going to define the test statistic differently. So if, for example, the statement is about the mean, we are going to take the sample, and we're going to calculate the mean of the sample, right? Our test statistic is going to be the x bar, right? For example, if the statement is about the proportion of the whole population, we're going to take the sample, and we're going to calculate the proportion of the sample. This is going to be our test statistic. If the statement is about the variance of the whole population, we're going to take the sample. We're going to calculate the variance of the sample. This is going to be our test statistic for the variance. Do you understand what does it mean, the test statistic? Right? So this is the value of the sample, which we're going to use in order to test the hypothesis about the population. So now let's talk about the plausibility of the null hypothesis. We're going to measure this with the p-value. What do you understand what does it mean, the plausibility? It is how much the, what does it mean?
It means if it's possible, check it. If it's possible, how much possible?
Okay, yeah, so if the null hypothesis is given, p-value tells us that how much the null hypothesis might be true. Okay? Plausibility. You can just Google this. What does it mean? Okay? So plausibility means that how much the null hypothesis is going to be true. And plausibility is the p-value, is the directly proportional to the plausibility of the null hypothesis. P-value is directly proportional to the plausibility of the null hypothesis. What does it mean? It means that if the p-value is bigger and bigger, it means that plausibility of your null hypothesis is more and more. Okay? If the p-value is small, it means that your null hypothesis is less plausible. Okay? For example, you're given some null hypothesis, you calculated the p-value, and this is equal to the 0.5%. Okay? Or 0.05, 5%. So for another null hypothesis, you calculated the p-value, this is 1%. Okay? It means that your first null hypothesis is more plausible than the second one. Okay? So plausible means how much it is true. Okay? So the problem is like this. So once you calculate it, so it is like a variance. Do you remember what was the variance? Right? We calculate a variance. It tells us, hey, how much the points are differentiated from each other. Right? But actually, if you just have the variance, it is really difficult for us to make any analysis just using one number, right? We usually use the variances in order to compare them with something else, right? So in a comparison of the t samples, we can compare the variances and make some conclusions. Here is the same. You've got the null hypothesis. You calculated the plausibility of this null hypothesis, right? Now you have to decide which value of the p is big enough for you and which value of the p is not big enough. Okay? So hopefully you're going to catch the idea. So we're going to do a couple of examples. So the data set can be used to measure the plausibility of the null hypothesis through the construction of the p-value. For example, if the so let's say, for example, you're given the null hypothesis, you calculated the p-value, and this p-value is smaller than 0.01. You decide how to choose the 0.01. Okay? You say that, hey, p-value is not big enough, it's smaller than even 0.01. It means that you're going to reject the null hypothesis. Okay? Because the plausibility of the null hypothesis is very small. Okay? So if, for example, the plausibility of the p-value of the null hypothesis is bigger than 0.1, so you decide this number by yourself, okay? Depending on what you're seeing, this is possible. What is the level of the significance, okay? So if the p-value is bigger than 0.1, you claim, okay, so this null hypothesis, so the p-value for this null hypothesis is big enough to conclude that this null hypothesis is plausible, is true, okay? So depending on the p-value of the hypothesis depends on the nature of the test, okay? So depending on the sign of the alternative hypothesis, we're going to define 3 types of the tests, okay? We're going to talk about the left tail test. So if the sign of your alternative hypothesis has the less sign, then we are going to take, we are going to calculate the test statistic, and we're going to take the area more lefter from your test statistic as the p-value. Okay? What does it mean? So let's do a small example in order to understand this. So let's say your claim is about mu, the average lifetime of the batteries is more than, less than 1,000. Okay? Or more or equal, let's say. More or equal to the 1,000. Do you remember what was the alternative hypothesis? So mu is less than 1,000, it's alternative hypothesis, and the null hypothesis is mu is more or equal to the 1,000. Okay? Now, I need to look to the sign of the alternative hypothesis. If the sign of the alternative hypothesis is left, is less, I'm going to use the left test, left tail test. What does it mean? So what do you think how I need to check this number, 1,000? So I am going to take a sample of, for example, 35 batteries, okay? And I'm going to charge this many times, and I'm going to measure the lifetime for each of the batteries. Okay? For example, the first battery worked for 1,050 charges. Okay? The second battery worked for 950 charges. Right? I calculated the lifetime for each of the 35 batteries, then I calculated the average. Okay? Then just using this average, I calculated the z-score for this one, for this 1,000. And this 1,000, we're going to talk about this later. Okay? So just like try to catch the idea. We calculated the z-score of the sample's mean. We took a sample, we calculated sample mean. We calculated the z-score for the sample's mean. And the area more lefter from the z, it's going to be the p-value. Okay? Why? Because the sign of the alternative hypothesis is less. If the sign of the alternative hypothesis would be more, you would do the same procedure. You would take the sample, you would calculate the average lifetime of all the batteries in your sample, you would find the z-score for this average of the sample, and you would take the right-hand side area if the sign of the alternative hypothesis would be bigger. You understand this? Huh? Z-score? Z-score. So we're going to learn about this. So just like it, understand which test we need to choose depending on the sign of the alternative hypothesis. Okay? If the sign of the alternative hypothesis is less, we are going to use the left tail test. What does it mean? I'm going to find the z-score, and I'm going to take this area, which is more left to your standard score, your critical point, as the p-value. So what I need to do with this p-value, do you remember? So p-value tells me how plausible the null hypothesis, right? If this area is bigger and bigger, it means that your null hypothesis is more true and true, more plausible, right? So you see, so I'm calculating this area, I'm taking this area as the p-value, okay? If the sign of the alternative hypothesis has the bigger sign, like this, mu is bigger than k, right? It's a sign of the alternative hypothesis. I'm going to find this critical point, or the test statistic, and the area more righter than the critical point, more righter than the test statistic, is going to be the p-value, okay? So let's start from the beginning. So we are given the claim. We need to state the null hypothesis, alternative hypothesis, okay? Then we need to figure out p-value. It is going to tell us how plausible the null hypothesis is, okay? We're going to compare this like a p-value with some number, which you decide from the beginning, okay? If the p-value is big, then you say, okay, so null hypothesis is true. If the p-value is smaller, then the null hypothesis is not true, okay? So this is how we need to calculate this p-value, okay? So we need to calculate the areas. Depending on what is test, we're going to define the areas differently, okay? For example, if you calculate one standard like a point, so which area you need to choose as a p-value? It depends on the sign of the alternative statement, alternative hypothesis. If the alternative hypothesis has the less sign, then we're going to choose the left-hand side area from your point. If your alternative test has the bigger sign, then we're going to choose this area as the p-value, okay? It is possible that you might have such a big area for the p-value as well, okay? It's okay. So once you choose one point for the standard score, you need to decide which of the areas you're going to choose as the p-value, okay? It depends on the sign of the alternative hypothesis. So now, if the alternative hypothesis have non-equality sign, we are going to measure the p-values as the summation of the areas on the tails, okay? We calculate the test statistic. We multiply the one test statistic to the second one, for example, in the standard normal distribution, because they are symmetric. Then we're going to measure these two areas on the tails, and we're going to sum this. This is going to be our p-value. Okay? So if it is clear, could you please tell me which kind of test we need to use for the following examples? A cigarette manufacturer claims that less than 1/8 of the US adults smoke cigarettes. So what is the null hypothesis? Okay, so our claim is the alternative hypothesis, right? It tells us that P is less than 0.125, right? 1/8. right? Our claim is alternative hypothesis. Null hypothesis is P is bigger than 1/8, and we need to use the left tail test in order to test this claim, okay? Because the sign of the alternative hypothesis is less. So let's talk about this another example. So the local telephone company claims that average length of the phone calls for their customers is 8 minutes. So we need to use the T-tail test, right? So our claim is mu is equal to the 8, right? This is going to be the null hypothesis. An alternative hypothesis is mu is not equal to the 8. And we're going to use the T-tail test because I have non-equality sign on the alternative hypothesis, right? Good. So once we found the p-value, we are going to compare this with the alpha, okay? So you define the alpha from the beginning. For example, you may take this as 0.1 or 0.1, and so on. If the p-value is bigger than alpha, you decide that this p-value is big enough for you. You are going to support the null hypothesis, okay? Because you say that if p is big enough for you, it means that your null hypothesis is plausible, okay? If p-value is smaller than the alpha, which you decide from the beginning, you said, okay, so p-value is not big enough for me. I'm going to reject the null hypothesis. Good? Okay, so depending on whether we're rejecting or supporting the null hypothesis, we need to decide the conclusion about the claim, right? Because if the claim is the alternative hypothesis, we need to support this if you're going to reject the null hypothesis, okay? So let's assume we made a claim, we constructed the null hypothesis and alternative hypothesis for our claim, and in this case, for example, our claim is the null hypothesis, okay? So if we are going to reject the null hypothesis, we need to reject the claim as well, right? We need to say there is enough evidence to reject the claim, okay? If we are not going to reject the null hypothesis, it means that we're going to support our claim, right? Because our claim is the null hypothesis. If we fail to reject the null hypothesis, we say there is not evidence to reject the claim, okay? Basically, we're going to support the claim, right? If our claim is the alternative hypothesis, right? Do you remember, for example, p is not equal to the 1.8 might be our claim, and this is going to be our alternative hypothesis, right? If you're going to reject the null hypothesis, it means that we're going to support the alternative hypothesis. Basically, we're going to support the claim, right? If you are not going to reject the null hypothesis, it means that we need to reject the alternative hypothesis, or we need to reject our claim, okay? So depending on whether we're rejecting the null hypothesis or alternative hypothesis, we need to decide whether we're going to support or reject the claim, okay? Because the claim is not going to be always the null hypothesis. It is possible that it is the alternative hypothesis as well. Okay, so you perform the hypothesis test for the following claim. You should interpret your decision if you reject the null hypothesis or if you fail to reject the null hypothesis. A cigarette manufacturer claims that less than 1/8 of the population of US smokes cigarette. Okay? So we calculated the null hypothesis. We defined the null hypothesis as P is more or equal to the 1/8. And alternative hypothesis is P is less than 1/8. Our claim is the alternative hypothesis. Okay? You perform the test, and you calculated the p-value, and let's assume that the p-value is very small. Okay? It means that we are going to reject the null hypothesis. Could you please tell me what kind of conclusion we need to make about this claim if we are going to reject the null hypothesis? The statement is true, right? We say that there is enough evidence to support this claim, okay? Because we rejected the null hypothesis, right? Okay, if we are not going to reject the null hypothesis, it means that there was enough evidence to reject this claim. Okay, we're going to reject this claim, okay? Because our claim is alternative, right? So we need to do the inverse conclusion about our claim, right? So if the null hypothesis is false, we say that our claim is true, right? Because our claim is alternative hypothesis. If the null hypothesis is true, we are going to say that our claim is false. Okay? Okay, so there is an algorithm. What you have to do step by step in order to test the hypothesis. So let's talk about let's talk about the hypothesis test for the population mean. So this is what you need to do in general, right? So we talk about the test statistics. So depending on which kind of claim we're testing, we're going to define the different test statistics, different distributions, okay? Because it tells us how to find the areas differently. So today we're going to talk about the hypothesis test for the population mean. So we need to, so from the beginning. So once we calculated the p-score, we need to compare this with the level of significance alpha. So let's assume that p is equal to the 0.0256. If you set the alpha, level of significance, at 0.05, so which is bigger? P is bigger or alpha is bigger? Alpha is bigger. What does it mean? P is smaller. Okay, so let's say P is smaller than alpha. Okay? What does it mean? It means that you think that P is not big enough for you, right? It's smaller than the level which you set up, right? You set up the level of the bigness of the p-value, right? If your p-value is bigger than this, you said, okay, so it's big enough. We say that the null hypothesis is true. If this is smaller than your level, alpha, you say that, hey, this is not big enough, okay? For the first case, p is smaller than the alpha. It means that we're going to reject the null hypothesis. For the second case, the p is bigger than the alpha, which you set up. We're going to say that we're going to fail to reject the null hypothesis. We're going to support the null hypothesis, okay? So depending on which kind of test we're going to use, we're going to define the different areas for the p-value. So, for example, you calculated the test statistic. The test statistic is equal to the 1.56. You're going to use the right tail test. So what is the p-value? So we need to put this test statistic, 1.56, right? Then we need to go to the table and find this area. So how to find this area? So we need to go to the Z table, right? Z table tells us the area until this point, right? I need to go to the Z table. I need to find the value of the Z. It's just going to be tell me the area until 1.56. This is going to be 0.9406, okay? You can check this at home as well. Go to the Z table, find the value of the Z, which is 1.56. This is going to be 0.94. It means that the area until here is 0.94. So that is why the area on the tail is going to be 1 minus this area until your point, right? So this is the area, and we are going to take this as the p-value, okay? Then we're going to compare this p-value with the alpha, and depending on whether this is bigger or smaller, we're going to decide whether to reject the null hypothesis or not. Okay, so this is another example of calculating the p-value if you're going to use the t-tail test, where the z-score, the test statistic, is going to be minus 2.63. We're going to go to the table. We find a value for the z, which is equal to the minus 2.63. We find the area, and we're going to multiply this area to the 2. Okay, because we need to add the second area, another area, on the another side of this curve, another tail of this curve, right? And those areas are going to be the same. So we are going to define the test statistic for the mean using this formula. Could you please write this down? So the test statistic, when we test a hypothesis about a mean, is calculated by subtracting the population mean from the sample mean and divide it to the standard deviation divided to the square root of n. So we're going to make the example. So do you understand what does it mean, this formula, how to do this technically? So for example, you're given the claim about the population mean, right? It's given, hey, the average lifetime of the batteries is more than 1,000, okay? So this is the claim about the whole population of the batteries. Our mu is going to be 1,000, right? Then we can take the sample. We can calculate the average lifetime of the sample. This is going to be x bar, right? If we know the sigma of the population, it's good, we can use this. If you don't know this, we're going to calculate the standard deviation of the sample, and we're going to take this as the s, sigma, and by dividing this as square root to the n, So which is the sample size? We can calculate the Z. Okay? So let's do an example. Quick example. So let's say a manufacturer claims that its rechargeable batteries are good for an average more than 1,000 charges. Okay? This is the claim. So the claim is, sorry, we need to do the example, okay? Quickly. Example. So what is the claim? It tells us that the mu is more than 1,000. Okay? What is the null hypothesis and what is the alternative hypothesis? So null hypothesis, alternative hypothesis is mu is more than 1,000, and null hypothesis is mu is less or equal to the 1,000, right? Okay? So we are going to use the right tail test. Okay? Now, we took the sample, we calculated the average lifetime of the batteries inside our sample. We took 100 batteries, we charged all of them a lot of times, and we calculated that in average, the lifetime of all of these 100 batteries is 1,000 T charges. Okay? So this is going to be our X bar. X bar is equal to the 1,000 T. And we also calculated the standard deviation for this sample of 100 batteries is going to be equal to the 14. Okay? Now what we need to do is we need to calculate the standardized test statistic. So Z is equal to the X bar minus mu divided to the sigma, or S in our case, divided to the square root of n. So this is going to be 1,002 minus 1,000 divided to 14 divided to the 10, right? Because n is 100. We take 100 batteries to our sample. So this is going to be 20 divided to the 14, right? Or this is going to be 10 over 7. Yes? Okay, so what I'm going to do with this, I'm going to put the standard normal distribution, and I'm going to find this point, Z, on this curve, okay? So let's say this point is here, roughly 10 over 7, okay? So now I need to decide which of the areas I'm going to take as a p-value, okay? In order to do this, I need to look to the sign of the alternative hypothesis. So if the sign, so which area I need to decide? The right point, the right area, or the left area? Right area, right? Because the sign of the alternative hypothesis is bigger, okay? So I need to find the area from the table which correspond to the more righter than 10 over 7, okay? This is going to be our p-value. So you can find this from the table. So this is going to be 0.0764, okay? You put this value here, right? 10 over 7. You found that the area from more righter than this point is 0.0764. Now this is our p-value, okay? We need to calculate, we need to compare this with the level of significance, which is 0.01. So which is bigger? P is bigger than alpha, than level of significance, right? P is bigger than alpha. What does it mean? It means that there is enough evidence to support the null hypothesis, right? P is big enough to support the null hypothesis, right? So we need to support the null hypothesis, right? P is big enough. So now, could you please tell me what was our claim? Is it the null hypothesis or alternative? It's alternative hypothesis. It means that we need to reject the claim, right? So if you are going to support the null hypothesis, we need to reject the claim, and we are going to say, at the level of significance, 1%, there is not enough evidence to support the claim of the manufacturer. Okay? So this is how we are going to test the claims about the population mean.